Howdy guys. In this video we're going to dive down a little bit more into what attributes can do in Houdini and how they can help us do some pretty nifty things. To start off, I'm going to make geometry, and we'll just start with a box. So say we're making an asset, and depending on the size of one of the primitives, or say the area or perimeter of a edge ring, we want to perform specific operations on it. Like, say we're building a procedural house, or setting windows and faces, or doing something like that. What we can do is use the measure SOP to create attributes about a surface's geometric data. If we go over into primitive, here by default our measure SOP is set to a perimeter type, and we can go ahead and override this name. Its default name for perimeter is set to area. So what we see here is that it's actually creating, I'm going to pin this so that our geometry spreadsheet doesn't update when I switch nodes, that as I increase the scale of our box, our area attribute updates accordingly. And this is pretty useful for determining the area of a specific face. We can also do this and use the perimeter to find the perimeter of a face, the surface area of a face, or the volume of a 3D object, or the curvature of a curve. In this case, we don't have a curve, so it can't calculate the curvature of a primitive in this case. So go back to area, and we're just going to call this prim area for primitive area, because this is the area of all of our primitives on our surface. And we can use the attribute promote SOP to convert and or perform operations on this primitive area. So we're going to go and grab from our original class as a primitive, and we're going to move this up to a detail so that we can see some information about our geometry object as a whole. So we can use this drop-down area and grab our primitive area attribute. And we'll see by default it's deleted our original primitive. I can click undelete and our primitive area attribute will still be there. Now if I go over to the details tab, I'll see a new prim area attribute. And this is the average value. So if I go back to here, this is the average value. Added all of these up and divided it by 6. This is the average value of the surface area of each primitive on our geometric surface. And we can change this to see the maximum or the largest face, the minimum or the small area of the smallest face, the mode, so the one that is the most common, as well as the sum, and add them all together. And we're just going to leave this in sum because that will be the surface area, so the combined area of all of the primitive areas for our geometric surface. And just like we were able to take this primitive area attribute and move it up to a details, we can actually do another attribute promote, and we can transfer this back down from a detail attribute to a primitive attribute. We'll grab our primitive area, and we've now deleted it from our details channel, and now our primitives, each primitive is aware of the entire surface area of the geometric surface. And we're going to go ahead and give this a new name so it doesn't override our previous. Same with this. We're going to call this surface area up here. Go check, there's our surface area name right there. And then when we go down in here, we're actually going to grab surface area instead. We don't need to give it a new name in that case. So then we have our primitive area for each primitive, and then the accompanying surface area for our entire geometry. So we have, let's go ahead and add a visualizer for our variable here, and I'm just going to call this area, and we're going to make a marker, and this will be a primitive attribute, and we're going to be displaying our prim area. Make a null node. Alright, so now we can see the primitive area on each of the surfaces of our primitives. So what does this do for us? Well, using this primitive attribute, we can actually group based off of the size of the surface area of a primitive. So we'll create a group node, and then in our base group filter, we can actually do @prim area to grab the primitive attribute. And base group is not, in this input field, we can't actually write full expressions in here, but we can write small, simple expressions. And it's important to remember we can't have spaces in here. A spacing will break the group input structure. So, well, in a normal attribute wrangle or some other vex inputs, we could have spaces, and here we cannot. So we'll just say if our prim area is like less than 2, enter, and now it will group all of the primitives whose surface area is less than 2. And I can go up here and we can add some, let's make this a polygon mesh and increase our axis divisions. Right now everything is less than 2. But if we go and let's make this 2.5. Same thing. So what if we, this is really helpful. You're like, well, why couldn't we just select normals pointing to the right or normals pointing to the left? Because geometry can get pretty complicated, and let's add a mountain sop to demonstrate this. So you'll see now that I've added a mountain sop with some more noise, our primitive sizes are a lot more varied, and it's still calculating the area for each primitive and then applying them to the group as we need. And now let's go ahead and look at some more things we can do with referencing attributes in group nodes. So I'll make another group, and in here we're going to grab our primitive attribute again, so primitive area. And here we're going to say if our primitive area is less than a certain percentage of the total surface area. So we want primitives who are relatively small in scale to the entire surface area of the object. So to make a expression call in the group parameter, input parameter field here, we need to actually use the left tick. This is the upper left-hand bar of your keyboard where the tilde is. This is the key to the left of the 1 on a standard keyboard. So we're going to do left tick, and then we'll type detail, because we're going to be grabbing let's go actually, because I want to grab a detail attribute. Let's in our surface area, let's not delete the original so that our entire object is still aware of its surface area. And we'll go back to our group node, and we're going to grab a reference to our surface area detail attribute. So we're going to do detail, and then this is the path to the node where that detail exists. So in this case, it could be our null, because it still exists there. I'm going to do null 1. And then we're going to say we're grabbing a detail attribute from this node, and then the name of the detail attribute we're getting. So in this case, it's going to be surface area. And then at the end, we need a float value here. This is if we were to be grabbing an attribute that had a vector property. So like say it had an x, y, and z position. This is the index or enum value for which x, y, or z we would be getting. So if it was 0, we'd be getting x, 1 we get y, and 2 we get z. So in this case, because there's only one, we just leave this as 0, and we'll end that. And now, if we end the tick here, it's going to group everything, because obviously each primitive area is less than the entire surface area. But if we go inside of our tick and do, let's see, times 0.1. So we're going to say things that are less than 10% of the total primitive area. And it looks like everything still is, so let's go a little bit smaller, and we'll do 0.01, so 1% of the size. And so now we're only getting, go back to our mountain and add some more noise. It's only going to be grouping, or change the noise values a little bit, primitives whose total surface area is less than 1% of the combined surface area of the geometry. Let's go back over here to our smaller fixed area. Let's go and give this group a name, so it's not just group 1. And we're going to call this small areas. That'll work. Or small prims. Now, in our small prims, we can create an attribute based off of the group. So we can apply an attribute and a value to all of the primitives in this group. So we'll do another attribute create. Here. And now we're going to create a new attribute, and we'll make this a primitive attribute. And we're going to say, let's just do small prims, or small prim. And we're going to make this a float. That's fine. We can do an integer. And we're going to say that if it is in this small prim group, we're going to give it that attribute with a value of 1. And by default, it will be 0. So we're going to say our small prims group. And then if we go back to our primitive details here, we'll see in our geometry spreadsheet, if we make this bigger, all of the geometry that is inside of our small prims group now has an attribute with a value of 1. And if it's larger than our small prims, then it has a value of 0. And now, we could go through and blast and say we're going to blast away small prims. There. Or we could say instead at small prim is equivalent to 1. You're going to see nothing changed, but if we do 0 here, then it will invert, and we'll see that we can delete objects away based off of just here, like we did with creating our groups based off of our attributes. Alright, so let's take another look at how we can use attributes to do some things with polyextrudes. So we'll go ahead and just subnet this guy, and then we'll go over here and make a grid. And we'll turn on the visibility on our grid. Alright, and I'm going to go and copy these over, and I'm just going to increase this to something like 20. So we get some more variation in our grid there. So, so the polyextrude node works very well with attributes. We're going to create the polyextrude, and we can increase the distance like normal. Let's pull this geometry spreadsheet down a little bit. And what we're going to be doing here is if we go over to our local control, we can modify the local attributes which have default names but aren't actually existing yet. So we can say distance scale and turn that on. And we can create an attribute that then we can then control with an expression to help us perform operations on our polyextrude or on the primitives that we are extruding. So to help visualize that, we're going to create an attribute. And we'll go into here. And this is going to be, I'm going to call it ramp. And this is going to be over primitives. And our primitive value here, we're going to name, let's see, let's just do like value from 0 to 1 across the z-axis, so we can get that normalized value with $BBZ. And let's put down a visualize note so that we can see what that looks like. These are fine. Attribute as is, primitive, and we want to see ramp. And here we have from red to black across our, like a nice gradient across the surface. And we can go into our poly extrude, and we'll see right now it's poly extruding everything. But we can change our distance scale to reference our ramp variable that we've created. We'll see right now it's not doing anything, and that's because modifying things at the primitive level, or I don't know of a way to poly extrude across a gradient at the primitive level. So if we instead do individual elements, you'll see we've now got the beginnings of something akin to stairs. And as we increase this value, there we go, nice stepped shape. And we can have some fun with this, and after we create our attribute, we can go in and do an attribute randomize, and then we can randomize that attribute. So we'll go to primitives and just type ramp, and now we've got this random thing. Looks kind of like, use this for a city generator or something like that if you wanted, or for random patterns. And yeah, so let's say we wanted to create something like this, but we wanted it to be smooth. We want a angled ramp rather than stairs. So to do that, we actually can convert our attribute over to points, and we're going to need a group for our front face. So I'm just going to group our front face. That'll be these top faces right here. And we're going to convert this group, because remember, if we go over here, our group attribute, our groups are an attribute with a value of 0 to 1. So we scroll through here, we'll see the primitives that are part of our group face. So we can actually do a group promote, and we're going to be promoting this group attribute to a points, from primitives to points. So we're going to convert from primitives to points, and we're going to be grabbing our extruded front, and we'll see now if we go to points, our extruded front group is now a point group. And we'll need to convert our ramp attribute from a primitive to a point attribute as well. So we'll do attribute promote and grab ramp. This will come from a primitive to a point. We'll see now our ramp attribute is listed over here in our points. And now that we have our point group and our point attribute for our ramp, we can create an attribute wrangle node and write a really simple expression here to set the py value, or the y position of all the points, to reflect our ramp attribute. So we can do at capital P dot y to grab the y position attribute of each of the points. And we'll just set this equal to our ramp attribute. We'll see, now we've got, let's go ahead and make this connected components again. So we have a nice smooth ramp here. And if we wanted to increase this, we could do at ramp times 10, and that'll make a steeper ramp value, because remember, the ramp is a value, normalized value from 0 to 1. So Now, and we could do all kinds of fun stuff with this. So let's say we wanted it to ramp up until a maximum value that we've defined, and then we want it to level off. So we could do that just by adding something like a clamp, and we'll just clamp our ramp value at the rate that it should increase, and we'll say clamp it from 0 to, I don't know, 3. And then we'll see that as our ramp increases, it will eventually hit the 3 and level off. And we can change this to a lower value, we'll level off slower, or a higher value, and it'll level off much faster. So let's go ahead and take at another way that we could use attributes and how to create new attributes with the attribute wrangle. So we're going to subnet this again, keep our node network kind of somewhat clean, and I'm going to make another grid. So in this grid, I'm going to just leave it default right here. It should be fine. And we're going to make an attribute wrangle. And in this attribute wrangle, we're going to write a simple expression to add a new point to the center of each of the primitives on our grid. So to do that, we'll just make int, I'll just call this new point, or let's say center point. We'll set this equal to a new point that we create with add point. This is the add point function. And this is going to reference the relative primitive and then the position that it should perform on, or the primitive that it should perform on. So we're going to say 0 and at p. And then we're going to need to run over primitives instead of points. And we'll see that now it's created a new point in the center of each of our primitives on our grid. So now that we have that, we can go ahead and use some other simple expressions to create a new group and add that group attribute to these newly created points, so that we can create the points and then add them to a group all at one go. So we're going to create a new string, and we're going to call this group name. And we're going to say our group name is center points. And then we're going to use the add attribute function. And the add attribute function needs 4 inputs. So the first is going to be the geo handle. So similar to our add point, it will just be 0. Is the geometry that we're working with will be the first, so 0. The next input is going to be our attribute type, and we're just going to make this a point attribute. The options here are going to be, we could have written point, we could also write prim or vertex. So the next input that we can create will be the name of said attribute. So in this case, we want that name to be group name. And we don't have to put this in quotes because it's already defined as a string here. I could have just put quote center points. And then the fourth and final is going to be the default value of this new attribute that we're creating. And so I'm going to make the default value 0. There we go. And so we go down and we can see our center points attribute has been added with our default of 0. So now we just need to set each point that we create here to have this attribute. We can use the set attribute function to set the attribute of our center points attribute to a value of 1 if it is one of our newly created center points. So again, we're going to start this out with the geo handle of 0. The attribute class is going to be point. The name is once again going to be group name because that's the attribute that we'll be modifying. And the element number is going to be the center point value. So that way we are setting this value to each of our new center points. The next value is the vertex of the primitive. We can just leave this as -1, which is basically means to ignore that value. Then we'll be setting the value that we want our attribute to set to. In this case will be 1. And then we have a bunch of different modes that we can use with set attribute. This could be sum, multiply, append if it's a string. And we'll just for now use the set mode. And we'll finish that out. And now if I scroll down in our geometry spreadsheet, we'll see that eventually our center points will have a value of 1, while our non-center points will have a value of 0. So we'll create a visualize node, and then change this to a marker. And we'll do, it's already a point attribute, so this will just be center points. Just add a null so that we don't get that double render. And there we go. We'll see all of our center points have a value of 1, and all of our, let's go ahead and make this a little bigger so it's easier to see. All our center points have a value of 1, and the non-center points that originally came on our grid have a value of 0. So, using this attribute, we have created a point attribute for each one. If we wanted to, let's say, add this automatically to a group, an actual group, not just an attribute that we could reference in a group, instead of creating a point here, we can instead create a point group. Update that, and we'll see now when we middle mouse click over hit this, we have a point group of center points, and there are 81 points in that group. And our geometry spreadsheet has updated to have group : center points. So let's say we wanted to do something like, if I have a tube, and I'll set the height to something around 2, and we'll decrease the radius scale a little bit. Looks about good. Then we can do something like the copy to points, and we'll just grab from our null node over here, and instead of copying to all points, we'll copy to our source group, or target group of center points. And we'll just go ahead and move this up by 0.5, I guess 1. And notice, let's say we want our grid to merge down here, but we don't need these extra points that we're copying to. So we can just make a merge. Let's move these to the other side to make this a little bit cleaner. And we'll just merge down from our group right there. And we see down here. And there we go. So now that we've looked a little bit into what we can do with creating custom attributes in Houdini, let's look at what we can do with some of the built-in point attributes that already exist in Houdini. So I'm going to go and do a demo of a common issue that I face. I end up performing operations like this quite often. I'm going to make a circle, and primitive is fine. Let's do the ZX plane. Let's do polygons. Alright. So let's say I had a shape and I want to duplicate it along all of the points in my circle, or along a swept curve or something like that. Well, if I go ahead and turn on point normals here, and if we look, this point normal attribute is something that's created by default in Houdini, but you'll notice it doesn't appear in our geometry spreadsheet anywhere. So if we want to create a new point normal for our circle, we can just add a point sop and update this to a normal value, and we'll see now that we have a public parameter that we can see in our geometry spreadsheet for our point normal direction. So what happens if I were to make, say I make another circle, and this will be ZX plane, polygons again. Let's go ahead and reduce these divisions down to something like 3 or so. We'll make this an open arc, and we'll set these arc angles to something like 180 to 360, so we get this trapezoid type shape. So polyfill this, and I promise there's a reason for me creating a shape in something like this. I just want something where we can see what direction it's facing. And I'll make a poly extrude, and we'll just increase the distance on this to make it taller, say 3. Alright, so now we've got our shape here. Let's make it a little thinner. Looks fine. If we do a copy to points here, and we copy this over here, something really not what we want happens to our shape on our circle. We'll see that they do get copied to the points, but if I made it standing up, I want it to duplicate to each of these points. Let's template this the other way. I want this shape to duplicate to each of these points, standing upright the way that I want on the points. And to do that, we can use the normal attribute and go ahead and modify this so that we can control the orientation of the objects that we duplicate along to the points. So a quick way to do this, let's say I wanted all of these to just stand straight upright. I can change this vex expression to value, and then I will be able to control the absolute orientation of the point normals for each of these points. So let's say I want them to point in this direction. So I want them to stay like this in the z positive direction. So I can just change my z normal here, and if I turn on point normals, I'll see all of the points now have a normal facing in that positive z direction. So when I go to our copy points, our objects now are copied all facing the positive z direction, just like they were originally. And I could do the same with the x value, or at a different vector if I wanted, and now they would all be facing towards the positive x direction. So what if I wanted these to all like lay out or face a specific direction, like relative to the point's position on the circle? To do that, we can actually not use our value, and instead we can just use the position attribute. And now each point will have a normal relative to its position along the circumference of the circle. And so when we go back and look at our copy to points, we get them all facing outward at towards the direction of the point normal that we've created. And if we wanted them to face in, we could just put a negative on our point normal there. You can see how we could use stuff like this to get some pretty cool effects or shapes. Alright, so I'm going to subnet this again. I've got one more example that I want to go over, and that's just how to modify some curves using point expressions and modifying the attributes in them. So we're going to start out with a line, just a really simple curve. We'll turn on points so we can see this, and we'll make it a little bit longer, and we'll actually go ahead and then just copy this parameter and paste that over here, and say 2 times the points for the length. There we go. Alright, so there's a couple different things that we could do modifying points and their position attributes on curves. So let's go ahead and make an attribute wrangle. And we're just going to start writing a simple expression to offset the points based off of their point number. So I'm going to say if, and we'll do at ptnum, so the local variable for the point number, and we're going to do modular 2 or %2 equivalent to 0. So what this will do is say if the point number divided by 2 is even, or that's what modular 2 is, equal to 0, then we'll perform some kind of operation on that point. In this case, I'm going to say we're going to move the p z position, so the z position attribute of the point. I'll just move this by like negative 0.25 or something like that. We'll see now every other point, or all of our even points, are moved 0.25 in the z-axis and the negative z-axis. And so say I wanted to make this a little bit more extreme, I could do else, and we could do at ptnum modulus 2 equals 1 for all of the odd points. And I could just write an else statement and a new line, because the only other condition for even is odd. But, you know, I'll do at p dot z, and we'll say we'll move this in the positive z-axis by 0.25. What did I break? I need else if. Just getting ahead of myself. Alright, so now I've got a nice zigzag line, and as I increase the length of my line, I continue getting this zigzag pattern as it gets longer. And we could do a couple more things with this. We can actually just go ahead and bypass that, make another attribute wrangle. And on here, we're actually going to just use some simple trig functions to get a similar shape. So we're going to do at px for the x position, and we'll make this a function of cosine. I'll just say at cosine at ptnum. And now we've got this nice smooth sweeping shape. So we could say, say we were going to use this to make like chain links in a fence or something like that, like a nice chain link fence pattern. Make a new line, and we'll do if, now that we have set the x position based off of our cosine, we'll say if that x position, so our at p dot x position, start this off correctly, and we're going to say if it is less than 0, so if it's on this side of the axis, then we'll do a z offset to get this again. I'm going to set that equal to the x offset amount. So we'll get this nice, like a chain link fence weaving through itself. And we can just do else at p dot z equals at, or negative at p dot x. So we get it going the other way. This nice zigzag pattern. And then if we wanted to clean this up a little bit after we've done the operations on our curve, we can just convert this from a polygon to something a little smoother, like a NURBS curve. It's a little less sharp. And then we can resample our curve. viewpoint, see it's pretty dense, but that's okay. We're going to go and resample by polygon edge so it doesn't, so we get some less deformations in there. And then we can drop down a refine so that we don't get like all of these points in here. We probably only need a little bit of them around these bends. As it goes straighter, we need less points. So we'll just do our first U and second U, so from the beginning and end of the curve. And we'll unrefine. And increase this value so that we get even less dense on our curve. That's a little better. And now we could just add a copy node. And we'll start making some copies, and they're going to be across the x-axis here, and we're going to want to probably scale them in the negative x direction each time we make a copy, and we'll get this nice alternating fence pattern here. And this will just keep going as we make more copies. And again, we could just increase the height of our fence line here. And to add some polygons to it, we can just use the polywire function. And now it's got some nice geometry. And this isn't perfect. We probably could have thought out the math for how these lines were going to overlap with each other a little bit more, but you get the idea. And there we go. So that's just a couple ways to use attributes with modifying some geometry in Houdini.